Hey guys, we all know that JavaScript is unpredictable, but if you know how JavaScript works under the hood, you can predict JavaScript. So today in my video, we are going to see how JavaScript works under the hood and how it runs our code and how it gives the output. So let's predict JavaScript. Hello guys, today we are going to see how JavaScript works and the two main thing, how JavaScript handles asynchronous code and how it is single threaded, and even if it is single threaded, how it is handling concurrent request, means multiple requests at a time. Okay, and why I am creating this video means I have gone through many videos in internet, but I cannot get the clarity of how JavaScript works. Basically, somehow the creators have messed up somewhere and they have given the knowledge in like very high level knowledge, and that just got bounced over my head. So I just want to make this more simple for the beginners and for the new learners. So let's just jump into my video. Okay, so let me just open some basic code. Okay, and if you can see there's some 4 or 5 lines of code, and you can just pause your screen and come up with the output from yourself. Okay, yeah, I hope you must have get some output, but let's just run this program and let's just see the output. Okay, yeah, so we got the output hello 1, hello 2, hello 3, and I think it is pretty straightforward that hello 1 and then this function got called, so hello 2 and then hello 3. Okay, now let me just run this second part, and here you are going to see the magic of JavaScript and why I said that JavaScript is like a mad girlfriend and for girls it is like a mad boyfriend. Okay, so just pause the screen and just try to come up with the output by yourself. Okay, let me run this program. Yeah, here comes the magic. Here if you see, the output is hello 1, hello 3, then hello 2, and this what the magic of JavaScript, and this what the callback function came into picture. This where actually the asynchronous thing came into picture. Okay, so we are going to discuss everything in this video in detail so that I can confidently say that after watching this video you are not going to be confused in your entire life that how this output is being generated and how to come up with the outputs of this async functions. Okay, so now let me just before going into the video, like the explanation, let me just run this final example. Okay, just pause the screen and just try to come up with the output yourself. Here you can see 1, then hello 5, then hello 2, then hello 3, then hello 4, and if I'll just call this function here, now just pause the screen and try to come up with the output. Okay, now if you see, things got changed 1 5 3 4 2. So that's what I said that एकदम से वक्त बदल गया, जज्बात बदल गई, जिंदगी बदल गई. So but अभी से नहीं बदलेगी, means from now onwards it is not going to be a confusion for you, because I am here to make all these things clear in very simple words basically. So let's just jump into the video quickly. Okay, so here you can see the 4 main components that we are going to discuss today. One is event loop, then call stack, then callback queue, then microtask queue. Just stay with me, and at the end of the video, like I am sure that you want to give me a treat. Okay, so just wait. So okay, I'm not actually going to give the literal meanings of event loop, call stack, callback queue and microtask queue, but I am going to give you the total flow and the feel of this concept, and after that whatever definitions you want to mug up, just go to internet and mug it up, but just stay with me, and then I am damn sure that you don't want any literal meanings. Okay, you will be able to answer all the questions. Just think, let me just create the loop. This is a loop and we can call it as event loop. This is a call stack, callback queue. We can call it as macro task queue, and one is micro task queue. Okay, so now let's just understand the basics. Okay, so as the name suggests, call stack means obviously we know the stack data structure, and even if you don't know, stack means last in first out. It's like a stack of let's just take an example of stack of a book. Okay, if you are piling up a book, so obviously the book uh, that you have kept last means at the top of the pile, you will be able to access that book fast, means you will be able to whenever you want any book, you can take that book fast, then second book, then third book. But if you see the book that you have kept the fast means the bottom one, you can take that book at last. So that's what last in first out, and it is a stack. And queue means first in first out. So obviously in a queue means you can see in the whenever you are giving an order in a pizza counter, so obviously if you have you got the token number earlier than a person, then obviously if you have came before a person means obviously your number will come first, then after you the person who came, like their number will come. So that's what means by first in first out, and that is queue. So this is some basics of stack and queue, and if you don't know, don't worry, you can go to other resources and just try to learn about what is stack and queue. But I think this much information is enough to at least have some basic idea, because as I am saying again and again, this video is not for beginners. But if you are beginner, you can just stay and just watch this video, and maybe after 2-3 months of working in JavaScript, you are going to get some more clarity. Okay, so yeah, actually we have diverted from topic, just let's come back to topic. So now let's just see this example. Okay, so when JavaScript runs this file line by line, first is encountered that okay, console.log hello one. So this is a statement that JavaScript has to execute. So what JavaScript will do is it will simply put this into a call stack, and this is a synchronous line, means this is a simple line, just we have to log something in our console, so it is going to be executed immediately. So we will be getting output hello one. Then this is a function. So this is a function means this is not yet called, but this also going to be lined up in the call stack, but this is not yet implemented, so we are not going to get any output till this point. Then call me came, so this is put it into callback like the call stack, and as our function is already there, so it is going to execute the function, and this function does not have any async things, so this is also going to be executed immediately. So we'll be getting hello 2, and then after this function again asynchronous like line, and the immediate executable line, that is console.log hello 3. So it will be simply put it to call stack, and it will be executed immediately. So like this we'll be getting these three outputs, and it is pretty straightforward. So okay, so now let's just go through this second, like the third example that we have got. Okay, so now again JavaScript comes to the first line, console.log simple line, it will be put it into call stack, it will be directly printing hello one. Then a function, but here if you see, we are getting a callback function here. Okay, just take a note that this is a callback function. Then a promise. Okay, now here if you see, we are trying to call the function, and we are trying to resolve the promise, and one simple console.line. So now what JavaScript do? Okay, here comes the main picture. So if you see, once we encountered any functions like this, like the callback functions like set timeout, and something related, whatever related to timers and the callbacks, these are going to be handled by wave API. This is, you can see, thought this as this is outside JavaScript environment. Okay, this is something that is there outside JavaScript environment, and these are going to handle the callback things. Okay, so you will be getting some more clarity, just take me. Okay, so set timeout is going to be handled by web API. Now let's just go through the total flow. So till now we have just understood the call stack, that whenever a whenever something is put into call stack, what our event loop does is it checks the call stack one by one, and whatever is on the like the top of the call stack, it simply just execute that. So that's how our one like we are getting the output. So whichever lines whichever things are encountered in the call stack is getting executed by the event loop. And as I said, set timeout, something related to timers and the callback functions, these are the asynchronous things, means that is going to be delayed in execution, that is not going to be executed immediately. If you know what set timeout does, it basically says that we have to execute this function after this much time, even if we have given here 0 second, but we are specifically saying that this is a asynchronous code and this is not needed to be executed immediately. So what JavaScript internally does is it offloads this type of callback things from its internal environment to the web APIs. Okay, I am going to give some more details regarding web APIs, but till this point just think it as a helper, means web API is a helper and that is outside our JavaScript environment and that is there to take care of the callbacks. So whenever we encounter one callback, our web API is going to take care of that. Okay, so now you got the point. Whatever comes to call stack, simply event loop every time checks for the call stack, and whatever is there in call stack, it simply execute that. And whenever one callback comes, our JavaScript uploads it, means it just gives its responsibility to web API. Web API is going to handle that. Okay, and what is now, here come the callback queue and the micro task queue. So as this name suggests, so whatever callbacks are there that are going to be kept in this callback queue, and whatever micro task, so promise is kind of a micro task, so promise is kind of a micro task, and this set timeout and all this is kind of a macro task, and these things are put in callback queue. You can have some more idea on what is the micro task, but today our main focus is to get the overall flow and how it works. Okay, so now just understand this flow clearly. Okay, so whenever one what event loop does is it continuously rotates and it checks the call stack, that okay, if something is there in call stack, it simply execute that and it simply displays the output. If, here comes the main point, if call stack is empty, it then looks for micro task queue. Micro task queue has more priority than the callback queue, so it then looks for micro task queue and then it looks for the macro task queue. So here what happens, if something is there in micro task queue, then it will be put in call stack, and as I said, event loop continuously looks for call stack. If something is there in call stack, it will simply stop everything and it will first execute that. So obviously at this point of time call stack is empty, that's why event loop has gone and checked the micro task queue and it got something in micro task queue, so it has transferred that to call stack, and from call stack it has executed that. Same, if nothing in micro task queue, as I said, the second priority is for macro task, means this callback queue, it will go and check callback queue. If something in callback queue, it will be putting that in the call stack and it will be executing that immediately. Okay, so till this point we are clear that if something is straightforward, if something is synchronous operation, it will be in call stack and it will be executing immediately. And if something is related to callbacks like set timeout or callbacks or promise, it will be offloaded to web APIs and it will be. So here you have to understand that what web APIs does. So till this point this set timeout is not executed. Okay, so what web API will do is web API will internally execute that point, that's set timeout. Okay, so if we have mentioned this set timeout like this, 2000 means 2 second, 2000 millisecond equal to 2 second. So what web API will do, web API will internally run this, and web API after 2 seconds it will execute that and it will put that thing in the callback queue. So after 2 seconds web API will put that thing in callback queue, and obviously as I said event loop is continuously running, and if call stack is empty, so now we after 2 seconds obviously web API has put that set timeout things in the callback queue. So our event loop will transfer that from callback queue to call stack, and it will execute that. So that's how we'll be getting the output. But as I said that promises are micro tasks and it had highest priority than callback queue. So now just let's go through this example. Okay, so first hello one. So hello one is directly printed. Then function call me, this is a callback type but not yet executed. Then we have declared one promise, and that promise is itself a asynchronous operation. So till now promise is also not executed. Then the function call is there. So now we are calling the function means and that function is a asynchronous operation, so it is uploaded to web API. So web API is going to handle that set timeout. So just have this in your subconscious mind that okay, now my call me function is of like the set timeout inside the call me is uploaded to web API and it is handling, and then immediately it comes to promise. So promise is also a callback function, so it is now being uploaded and it is also handled. And as I said that both promise is going to be handled by microtask and callbacks are going to be handled by callback queue. And if you see in both set timeout we got the same time, like the 0 0 second. So obviously we have after 0 second our function promise will be resolved, and the result of that promise will be put in the microtask queue, and for the result of the callback will be put in the callback queue. And as event loops look out for the microtask queue first, it will be uploading the content of microtask queue first and then callback queue. And that's why when we ran this program we got this output 15342, because first console.log simply directly it will be printing hello one. Then as this is a function not yet executed, this is also a asynchronous function not yet executed, then we are calling call me and promise, and both has the same timeout. So our here I have explained that our event loop first looks out for microtask queue, then for callback queue. So it looks out for promise queue, and same time callback queue has also got the result for this set timeout. But as the priority is for promise, so the things inside promise is going to be displayed first. So here if you see, this is a normal like okay, so let's get back to the example. So here if you see, this is a normal line, so this is put it to callback stack and directly it got printed, so hello one. Then our code encounters call me, but this is a function and this is asynchronous function, so till this point this function is not yet called and it is asynchronous function, so no output till this point. Then a promise, it is also asynchronous function and not yet resolved, so no output. Then if you see, we have called call me function, so obviously this call me got a asynchronous operation and that is set timeout. So set timeout is going to be uploaded to web API, so web API will be running this in background. And till this point you are with me, I am assuming you are with me. Then promise is there, and promise is also a asynchronous function, so this also is going to be uploaded. And till this point also no output, because obviously these are asynchronous function and event loop is now giving priority to call stack. Then console log hello 5, this is straightforward function and this will be put to callback stack and immediately this is going to be printed. So that's how we are getting hello 1 and hello 5. And here comes the thing, as I said, both timeout has got the same time, that's the 0 0 second. Means obviously we will be getting the result in callback queue and promise queue, like the micro task queue simultaneously. For the call me function callback and for this promise, we will be getting the output simultaneously in this callback queue. Okay, but as our event loop is giving priority to promise, so what it will do is it will first transfer the micro task queue things, mean the promise result to the call stack, and it will be displaying the output for that promise. So that's why this hello 3 got displayed first, then the resolved result of that promise, that is hello 4, and at last now our event loop has checked the microtask queue also and our call stack is empty, so it is again going to check the microtask queue and nothing in microtask queue, then it will go and check the callback queue. So we got obviously the result of that callback is there in the like the function is there in the callback queue, it is going to transfer that to the call stack and it is going to give us the output for that callback. So that's how we are getting the output hello 2. So let's just come with me and just try to run this in your subconscious mind. First it encounters hello1, so obviously it is going to print hello1 directly. Then call me function is there, and it is asynchronous function. So like the set timeout is asynchronous thing, so it is going to be uploaded to web API. Then promise is there, so promise is also asynchronous thing, so it is uploaded. Then call me function is there, but as it is asynchronous and web API is handling that is in background promise, this also getting handled in the background. But at this point of time, call stack is empty, call queue is empty, callback queue is empty, and microtask queue is also empty. Then we encountered hello5, so this will be put to callback stack, and this is going to be executed immediately. Then as I said, both promise and our callback function got the same time, so simultaneously it is going to be put like callback queue has the result of this set timeout, and microtask queue has the result of promise. But as our event loop is giving priority to microtask queue first, so it is going to be execute the promise things first. So that's why we are going to get hello3 and hello4, because this is related to promise, and then we are going to get hello2. So this is the flow, like this is how our JavaScript handles the things. Means just for the summarization, we can have this event loop, stack, and our two queues. As I said, the q1 is macro task, that is callback queue. Q2 is micro, and our main helper and game changer is web API. So event loop continuously runs, and it checks for callback stack first, and whatever in callback stack, it simply take out that one by one, and it simply execute that. And if callback stack is empty, it goes for micro task queue, that is promise is kind of a micro task, so it goes for micro task queue. And if something is there in micro task queue, it executes that first. And if both callback stack is also empty, micro task is also empty, it is going to check macro task queue. And if something is there in macro task queue, it is going to move that to callback stack, and it is going to execute that. And as I said, whenever something related to async come, JavaScript internal environment is not going to handle, it is going to upload it to web API. So side by side web API is also running, and that's how the callback works. Means whenever we encounter callback, we will simply upload that to web API. Web API will be running that. Let's say we got a set timeout, and it is scheduled after 2 seconds. So once the set timeout encounters, we simply upload it to web API. Web API in background, it will be running that function, and obviously after 2 seconds it is going to execute. So after 2 seconds it will now the time came for the execution. So what web API will do, it will give that, and it will put that in the respective. So if it is a promise, it will be putting in micro. If it is a callback function, it will put it in a macro. So after 2 seconds it is going to put in macro, and obviously event loop is continuously checking. And if at that time call stack is empty, then obviously first it will check for micro, and if it is also empty, it is going to check for macro, and it will be transferring that things from macro to call stack. And now as we got something in call stack, it is going to be executed. And that's how this asynchronous programming works in JavaScript.
I think length of the video itself is justifying. JavaScript is how much unpredictable. So I have divided the video into two parts. We are done with the part 1 where we have seen how JavaScript is working for front end, and now we are going to see how JavaScript is working in back end. So go and check out the part 2. Bye.